Oh, do you have your packet at home? You just,
Yeah.
okay. Do you want another one, or do you want to do it on paper?
It's fine. I can just do it on paper.
For sure.
I'll just copy it down.
Okay. All right, so again, we're talking about these special right triangles. We kind of just did this in your warm-up. If the hypotenuse is 1, what is the short leg of this triangle? 1/2. And what is the long leg?
3/2.
Okay. And in the 45-degree triangle, if your hypotenuse is 1, what are both your legs?
2/2.
Okay. Okay, we are going to use those values to create the unit circle. All right. I'm going to do a lot of color coding with the circle, so if you have colors or you like to use colors, go ahead and get them out. So what we're going to do here today is you're going to understand where all of the values for these blanks come from. You're going to know degrees all the way around, radians all the way around, and ordered pairs for everything. And then you're going to have next class a timed quiz on this. I will give you 5 minutes to fill in everything. Okay? Sounds scary. It's not memorizing, it's understanding, like, oh, this is the pattern and I see where that comes from. Like, I see why this does what it does. It's not just straight memorizing. If you just memorize, it's just not good. Because if you screw one thing up in your memorization, you won't catch it. You know what I mean? But if you understand where it all comes from, it is not bad, guys, I promise. All right, so I'm going to start over here at 0 degrees. We're going to start with a few things we know. Okay, then what is up here? 90 over here.
180.
Down here.
270.
Yep, and then if I went all the way around? 360. I know there's not another blank over there, so 90, 180, 270, and I'll write that under it, 360. Okay? All right, I'm going to switch to blue. So guys, think about our special right triangles. What angles do we talk about in our special right triangles? And what's the other one? 30, 60, and 45. That's 3 angles, right? Conveniently, I have 3 spaces right here. So what order do you think they're going to go in? 30, 45, 60. Okay, I'm going to start with the 30. So that is 30 degrees from my x-axis, right? If I come over here and went 30 degrees back from 180, where would I be? 150, so I'll also make that blue. What about this one down here being 30 degrees back? No, 30 degrees.
Oh,
I'm only doing the blue one, the 30 degree one, so 210. And then what do you think the one in the 4th quadrant over here will be? So 330? Okay. Those 4 are all blue for a reason, okay? They're all 30 degrees from the x-axis. So what do you think is going to be my next degree in here? 45. So I'm going to make mine green. You do whatever color suits your fancy. Now, 2 ways you could think about this. You could go 180 minus 45, or even just think how far apart are 30 and 45? 15. So I would just do 15 in whatever direction you're going for. So, what's this one going to be in the 2nd quadrant?
135.
135, good. In the 3rd quadrant, that middle one? Good. Come on. In the 4th quadrant? 315. Okay. But does that make sense where they're coming from? Okay. All right, then I'm going purple. What is the last angle we're talking about? 60, yes. Okay. So again, you can think 60 back from 180, or what's the difference between these two again? 15. So what is this going to be? 120.
So 80.
Did I lose you?
Oh, I got it, never mind.
You see it? Okay, what's the third quadrant one going to be? 240. Fourth quadrant? So honest. 300. Good. Oh no. All right. Questions so far? Do we get the degrees? Make sense? Okay. All right, we're going to do radians next. So, starting over here at 0 degrees is also 0 radians. Do you know 180 degrees? What's that as a radian? Pi radians, right? Okay, remember 180 and pi, we do that with our converting. Okay, so this is pi. What would that make 90 degrees? Yeah, pi over 2. What about 270? 1.5 pi, we usually say 3 pi over 2. And if I went all the way around the circle, what would that be? 2 pi. Okay, so let me write all these in for you. Pi over 2. Questions on that? Yeah.
What's the 270?
3 pi over 2. That's like 1.5 pi? Half pi, 1 pi, 1.5 pi. Yeah? Yep, okay. What's wrong, Bonnie? Here, I have extra. Here you go. Okay, now we're going to do all the blue ones in radians. So our 30, 150, 210, 330. What is 30 degrees in radians? Like you could do that conversion quickly, right? So pi over 6, yes? You're not wrong when you say 1/6 pi. It's just you're not going to see it written that way, so we always write pi over 6. Okay, so all of these blue ones that I have in blue up here, they are all something over 6. I'm going to write over 6, over 6. Are you guys okay?
Yeah.
We'll pause for a minute, guys. Bonnie, what did you say? How did I get 2 pi?
Yeah.
So if 180 degrees is pi, what's 360 degrees?
Oh, okay.
You see it? And like this is halfway to pi, so half to pi. No, it's 0 radians or it's 2 pi radians if you go all the way around. It's just like it's 0 degrees and it's 360 degrees. Okay? All right, we okay now? So if you actually did the converting, 30 times pi over 180, 30 goes into 180 6 times. 1.5 pi? Half pi, 1 pi, 1.5 pi, 2 pi. Yeah? Okay. Okay, back up here, guys. So the over 6s. The easiest way to kind of, you're almost counting your way through this. This is 1 pi over 6. This one is going to be the next something pi over 6 that doesn't reduce. Because if I did 2 pi over 6, that would reduce, right? 3 pi over 6, 4 pi, 5 pi over 6. Good. And then you keep going. 6 pi over 6, that's pi, right? So that makes sense. We're going in order. What's next? 7 pi. And then what do you think that last one's going to be? 11 pi over 6. And do you guys see how that's almost 2 pi? Okay, so this is 1 pi over 6. I'm like 1/6 of the way to pi. Okay?
Oh, okay.
So to get all the way over here, it's the next fraction that doesn't reduce. Because 2 pi over 6 is in here, 3 pi over 6 is here, 4 pi over 6, 5 pi over 6. You just keep going around with the irreducible fractions. Because 6 pi over 6 is here, 7 pi over 6, 8 pi would reduce, 9 pi would reduce, 10 pi would reduce. Okay, 11 pi over 6 is all the way over here. Yeah? Okay. Are we okay with the blue ones? All right, let's do radians for the green ones. What is 45 degrees in radians? Pi over 4. Another way to think about it, it's halfway to pi over 2, right? So that makes it pi over 4. Okay, so all the green ones are over 4s. What do you think 135 degrees is in radians? What's that numerator? 3 pi over 4. Good. What about the third quadrant green one? Yes. And the fourth quadrant? Yes. Are you guys seeing it? Like you see the patterns? Okay. Okay. What are you missing? Okay, so this is 1 pi over 4, right? 45 degrees. If I actually did the conversion, I want to know what 45 degrees is as a radian. 45 goes into 184 times, so this is pi over 4. So that's why I'm starting there. How they relate to the x-axis, all of these are going to be over 4s. All the green ones are. Like they're connected. This is why I'm color coding. Okay? Do you understand where I got the 3 pi from?
Because you have to go 1, 2, 3.
Yeah, because 2 pi over 4 is this. 3 pi over 4. 4 pi over 4 is pi.
I thought it was 3, 6.
We will get there, guys. Okay. All right, so let's do the purple ones. Everyone do not yell out what it is other than the very first one. It would be pi over what? Okay. So these are all over 3s. Don't say what they are yet. Give people a chance to think. Okay, think about it for a second. I heard you. Okay. Second quadrant one, what's it going to be? 2 pi over 3.
It's going to be the best way. Like, we have 5 minutes to do this. Are you better off going by 6ths and then by 8ths? Or like doing 1/12 at a time around, or 1/8 at a time around?
I don't think I've done anything with 1/12 and 1/8 for you here today.
No, like, in the entire way to halfway, it's divided into 6.
Yeah.
Because then there's like pi over 6, and then that's actually 2 pi over 6, and then this.
I think whichever way makes more sense to you. For the degrees, I think it's easier to go like 30, 15, 15, 30, 30, 15, 15, 30, like to add around. For the radians, I would do all your over 6s, all your over 4s, all your over 3s. Like, I would just do them in groups.
Okay.
I find that faster, but that's how my brain sees it. So you'll figure out how your brain sees it. And don't worry, I'll give you a chance to figure that out today. All right, so third quadrant, what's it going to be? 4 pi over 3, good. And the last one?
5.
Okay. How do we feel about the radians? You see it? Better. Better now? Okay. All right. So now we also need ordered pairs. All right, it's a unit circle. That means my radius is 1 unit long. So what would the ordered pair of that point right there be? 1, 0. What about up at the top? Over to the left.
Negative 1, 0.
Good, and at the bottom?
0, negative 1.
Okay. All right, so let's think about where these other ones come from. So this right here is my 30-degree angle, okay? Which makes the x part of this, to get to this point, the x is the long leg and the y is the short leg of a 30, 60, 90 triangle, right? So what is the long leg in a 30, 60, 90? You have it written right above your circle. Root 3 over 2, and what's the short leg? 1/2, right? We did that up above, like if I scroll up, yes? Those numbers that I said you'd become very attached to. Do you guys get why the x is the long part and the y is the short part?
Yeah.
Does that make sense? Let me draw it over in case you're not ready. We'll draw it on that part. Long, short. Okay, horizontal distance is x, vertical is y. Does that make sense? Y is root 3 over 2 and then 1/2. Okay, I need some head nodding or some, I don't know where we're going. Yes, we're okay? No? Okay. But we're only doing this one so far. Do you get this part? Okay. That's all I need so far. Baby steps here. Okay, so let's think about it. All of the other ones I've done in blue. Do you guys see how it's the same triangle, just in a different quadrant? So the ordered pair is going to be the same, except for what?
Sine.
The side. So what's this one going to be?
Negative root 3 over 1/2.
Yep. And in the third quadrant, they're both negative. Fourth quadrant, only the y is negative. Okay. All right. The green one. That's a 45, 45, 90 triangle. That's the easy one because your x and your y are going to be the same thing, right? What are they going to be? Okay. So, if you know those, you know all the other quadrants. Your x is negative, but y is positive. Both negative. Positive x, negative y. We okay with the green ones? Yes, okay, yes, good. I see a few faces that are like, make sure we're okay. You're okay with that now? You know everything right now. That's awesome. Okay, so the last one, this purple one. Think if I drew in that right triangle. Yeah, do you guys see how the x is now the short part and the y is the long leg? So they just get switched. So this is 1/2 root 3 over 2, and then just signs in all your other quadrants. All right, guys, questions? Any piece of this you need me to explain? Or that you're like, man, I just don't get purple or whatever color we're talking about. Any part of it. Yes.
So, whatever value of X you get for the distance of that.
Yeah, because think if we were trying to plot this, wouldn't you go like over this far, up this far? Like, because what you're telling me is the ordered pair for that point, that point, that point. Okay.
5 minutes to do this.
Yes. We're gonna practice here in a second, guys.
For the greens,
Yes.
for the gradients, is it, you go by the next one, or you scroll back?
Yep, for all of them. So that's 1 pi over
For all of them?
all of them, yeah.
Oh, okay.
Yep.
Oh, okay.
Do you see it?
Yeah.
Okay. All right. Yes. For all of them? Okay. So you get these 3, right? The original ones, like that's just, you could convert it quickly in your head. These you'll learn very quickly. All the over 6s then. It's irreducible fractions is what you're doing. Because this is 1 over 6, 2 over 6, 3 over 6, 4 over 6 would reduce. 5 over 6 doesn't. So I know that's my next over 6. Because if I'd gone through like 2 pi over 6, well that's right here. 3 pi over 6, 4 pi over 6, 5 pi over 6. And you just keep working around. It's the same with all of them. 1 pi over 4. 2 pi over 4 is that. 3 pi over 4. 4 pi over 4, 5 over 4. You see it? Okay. All right. Guys, we're going to practice. So, clear, like, just close your notes, turn it over. This is not for a grade. This is so you can see how 5 minutes feels. Okay? And to be like, oh, I know stuff, or okay, I thought I knew stuff, I don't know.
I'm gonna do this so
So when I pass it, not guys, just leave it upside down on your desk. No, not for the time one. It says like positive, negative up here. Just ignore that in each quadrant. You're just filling in what we know. Okay? So leave it upside down until everybody has one, and I say go.
Stop. Flip it over though. Don't flip it. What if I just go
It's just practice, guys, okay? But you'll see what you know and how it feels. Everybody have one? Yeah. Ready, go! Okay, not out loud, guys. Okay, guys, that was 5 minutes.
Slide it in right there.
Oh.
We're so excited. I'm trying to look like
Okay, guys, so check who's the one we filled out in your notes. Did you do it right?
No.
And how close were you? Like now you know what 5 minutes feels like, so you need to write. Did you do better than you thought you would? Yeah, okay. So double check, make sure you wrote the right things down.
I almost wrote 0 degrees.
Yeah,
Did you notice it? I did that wrong. That was really ugly.
One second.
Is that us?
You just mark it as like
Yeah.
the calculator circuit is short, and this little half of these that are actually short. So you should be fine. Some graphs. All right, guys. Pause for lunch. All right, so your triangle. Again, right angle goes on the x-axis, okay? And this little central angle I'm going to call theta. Theta, T-H-E-T-A, that's what that is. Greek letter. All right, do we understand this is x and this is y? Right, makes sense? Just like we were doing on the circle. And then the hypotenuse here, do you see how that's the radius of the circle?
Yes.
Yes, does that all make sense, all those labels?
Yes.
Okay. What
The square root of
is, that's theta?
No, the R.
Oh, that's an R. Yeah.
Is that theta or?
Theta, yeah. You'll get very used to thetas as we go through. All right, so what we're doing with this, I want you to set up for me what is the sine of theta based on this little triangle. What would you tell me? SOHCAHTOA, right? Like, what is sine?
Oh, y over x.
Y over R.
Y over R. Y over R. Remember, sine is opposite over hypotenuse? So if I'm starting with theta, this is opposite, and R is my hypotenuse? Yes? SOHCAHTOA? Remember this? Sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. Yeah? Okay. Did you like block out geometry? Is it like a bad memory?
Show shackle. Show.
All right, cosine theta. What's that going to be? X over R. What?
What does A stand for?
Adjacent?
Wait, how do you draw a theta? Is it like a O with a line through it? Or is it like a...
Yeah, and it's kind of a little more, like not just a straight line, but a little, yeah, it looks like a Pokeball. It does. So what's tangent of theta going to equal? Y over X. So guys, that should have been a review, but I'm a little concerned that it's not. It is? Okay. Okay. All right, then we've got to think about the reciprocals of this. So cosecant is what is related to sine. Cosecant is going to be y over r. I'm sorry, r over y. You flip your sign. Secant goes with cosine, so that's going to be r over x. Cotangent goes with tangent, so that's x over y. It's just the reciprocal. You just have to remember which one goes with which one. None of the cos go together. if you want to think, I never think of this way, but if you however you want to say that. Yeah, if you want to think of that, you certainly can. I would not, but it's up to you. All right, so are we okay? That's just how you set up the ratios. All right. If we're on the unit circle, what is my radius if I'm on the unit circle? 1. So look at sine of theta up above. That's y over r. R is 1. What does that really make sine? Just y, yeah. So this is only on the unit circle. What would cosine of theta be? Okay. And we can write tangent, but it doesn't really change. It's still just y over x. And then that's just math humor for you there. Sine of gerene over cosine of gerene. What's that going to equal? Tangerine. You'll find that math jokes are always extra cheesy. Okay. It looks like an orange. It's tangerine. Okay, guys. So let's actually use this stuff now. Tricky practice, yes. All right. We'll do the first couple together. So sine of 3 pi over 2. You can pull out the unit circle you made, rather than having to flip back and forth in your notes. Where is 3 pi over 2? To the bottom, right? Yeah. Okay, and if I'm talking about sine, do I want the x or the y? Sine is y, so what is the y value at 3 pi over 2? Okay, we're done with the first one. Yeah. Okay, so cosine, 5 pi over 4. So where's 5 pi over 4? Which quadrant am I in? 3. Cosine, is that x or y? X. Okay. What is the x at 5 pi over 4? Okay. All right, and let's do 5 together because it's got a negative. Should really have that in parentheses. So the sine of negative 4 pi over 3. That just means you're going backwards around the circle. So this is negative pi over 3. This is negative 2 pi over 3. This is negative 4 pi over 3. Okay? Remember coterminal angles? Like that's the same spot as 2 pi over 3. All right. It's the sine of it. So do I want x or y? Y. What is the y value at that point on my circle? Okay. Do you guys see why knowing the circle is going to be pretty important? Yeah, these are kind of hard to evaluate if you don't know your circle. All right. So don't do 13 or 14 right now, but do the rest of those 6 through 12 for me. Okay, I'll give you a few minutes here.
Wait, how do we know this? What if it's not on the unit circle?
It will be, or it will be coterminal to something on the unit circle, but I'm not going to give you like the sine of pi over 12. Okay?
Okay.
Yeah. Later I will, but with what we're doing right now, I will not. Yeah.
What does the brackets on the things mean?
The brackets. Like the parentheses?
Yeah.
It's just saying the sine of 7 pi over 6. Nope. like sine and cosine way more than tangent?
Yeah.
Wait, no. It's one. Just repeat. Alright, just be repeated. Just be divided by half.
Okay, yeah, you won't have a calculator for any of this stuff, okay? So don't practice with it. Y over X. Yep.
All the things to keep in mind.
That's why if the circle can become just automatic for you, it's pretty helpful. Yeah. Somebody last year asked if they could get it, like, what would I do if they had it tattooed on their hand? Is that cheating? Like, first you would really have to, like, trust your tattoo artist to draw the right unit circle on you, so. Don't go get a tattoo, just look. Alright guys, let's go through these. Alright, so sine of 7 pi over 6. So that's in the third quadrant. I want the y value. What do you think? What'd you get for number 6?
It's
Negative 1/2, yes. Okay. Cosine of 330. So yes, I could still ask it in degrees too. You know where 330 is? What'd you get for that? Sine of negative 270. 1. Cosine of pi. Sine of 11 pi over 6. Tangent of pi over 3. Tangent of pi over 2. Alright, say undefined for me, okay? Yep, definitely do undefined. You can abbreviate it, that's fine. Don't give me like the no solution symbol though, say undefined, because it's dividing by 0, that's the issue, okay? Alright, a couple of things that will help you here. Let's see. I'll those up for now. I don't know if you guys were noticing, you didn't have that many tangents to do on there. But you're going to be dividing the same values over and over and over. So you need to start recognizing that every time I do the tangent of one of the over 6's, I'm going to get root 3 over 3. You just have to determine the sign based on what quadrant you're in. Every time it's tangent of something over 4, it's 1 or negative 1, depending on the quadrant. And tangent of any of your over 3's is always going to be root 3. And then figure out your sign. Okay? Cotangent then, because it's the reciprocal, you see how they're connected here? These would be the exact same. So jot these down if you want to. You may just recognize them after you've done enough of these. What? Does that make sense to you guys where these are coming from? Rather than doing the math of, okay, 1/2 divided by root 3 over 2. All right, flip, multiply, rationalize. You get the same thing every time. And you can always think about the tangent over 6. You need 2 3's, you can get to the 6. This just says 3. It has, like, it's just a way to help remember it. It has nothing to do with the accuracy of it. Questions so far? I just want to practice a few of the secant, cosecant, and cotangent ones too. So. All right, so once you have that jotted, so just bounce. once you have those, jot down what you need. Write down these 6 somewhere. You can squeeze them in somewhere. It's not like you need a lot of room to do them. And then I want you to try to figure out what those values are. Can I move it up, guys? Does everybody have the top part written?
Yeah.
Okay. There you go. Sorry, guys. Okay. Cosecant. Can you think of what it would be for sine?
Whatever.
Well, sine of this would just be root 2 over 2, right?
Oh yeah.
Flip it then for cosecant. You do it for rest. You think more on secant, cosecant, and changing cosecant. Do you want me to walk you through one of these? Okay. So cosecant 3 pi over 4. Secant of 5 pi over 6. Yeah, sorry, that's secant. 3 and 6 are both secant. Alright, so cosecant of 3 pi over 4. I'm going to think of it as sine of 3 pi over 4 to begin with. What is the sine of 3 pi over 4 equal to? Root 2 over 2. You just always have so many 2's. The cosecant then is just the reciprocal of that. Okay? So it's just 2 over root 2. But if you rationalize, now we have so many 2's. 2 root 2 over 2, which is just root 2. Okay? There's some very pained faces right now. Alex is good, alright. Where did I lose your mind? Okay, do you get the sine of 3 pi over 4? Okay, so you're okay with this. Cosecant just means flip that. So that's why I did 2 over root 2. But we're not going to leave it like that. We're going to rationalize, which gives you 2 root 2 over 2, and reduce it to just root 2. Okay? They're just reciprocals. So you have to know what I'm going to do. You've got plenty. Okay, so sine cosecant. Cosine of the secant. So since it's cosecant, I'm going to treat it like a sine.
Oh, that's why.
I'm just going to use the sine of 3 pi. So this is root 2 over 2.
That's 3.
So that's to actually turn it into cosecant. Okay.
Oh, I did think
Guys, the more you do of these, the quicker you get at them, the easier they become. Eventually, we'll have trig quizzes, which are like, I'll give you 20 of these, and I'll give you 3 minutes to do them. That's not immediate, okay? That's after we've practiced a lot of them, okay? You get that good at it, I promise. You'll just see it. We'll do so many repetitions. And the first one starts out as just sine cosine. All right, guys. Let's go through these. We've got just 5 minutes left. All right. So tangent of 7 pi over 6. What did you get? Root 3 over 3. Yes. Any questions on that one? Okay. Secant of 5 pi over 6. So I'm thinking cosine of 5 pi over 6. Then I'm flipping that. So what'd you get? Yes, negative 2 root 3 over 3. Any issues there? You got it? Yes, yes. Both of you got it? Okay, good. Root 3 over 3. I don't know why the little arrow thing won't go away.
It's a not negative.
No, so 7 pi over 6 is third quadrant, right? X and Y are negative, so when you put them together, what does that make? Okay. Yep. Okay, cotangent of 2 pi over 3. So I'm in the second quadrant. So that's one positive number, one negative number. So I know my answer is negative. Yes. Questions on 4? Okay. All right, 5. Cosecant of negative 5 pi over 6. You're going backwards around your circle. That's third quadrant. So you're thinking of it as sine negative 2. Yes. All right, and then the last one, secant of negative pi over 3. Think about where negative pi over 3 is. Secant's related to cosine. 2.
Good. We have to rationalize these.
Yes.
That's why all of them look.
Yes, you do need to rationalize these, okay? Questions? I can walk you through any of these, guys. Anything you need. You'll get good at them, I promise. I promise. And you have to get good at them, because the trig quizzes go the whole year. Okay? Because you have to remember it for calculus. So, trig, these, the quizzes on these. Trig quiz, yes. Okay.
Wait, when is our first one?
It's just not for a little while.
Just this or other stuff too.
So it'll start out with just sine, cosine, tangent. Then we'll add in secant, cosecant, cotangent. Eventually you'll have some inverses, but that's not till later. Not every week for the whole year. Usually like 4 or 5 a quarter. So almost. All right.
Yeah.